My name is Tony Carney from Cooper Lighting. Thank you, Omar. Sorry, I do not speak very good Spanish. Mi Spanish is muy mal, so lo siento. But I want to tell you about linear LED. So I have been working on linear LED for the last 3 years. They let me out of the lab to come give this presentation, so thank you. Linear LED at Cooper is very important. Many different brands, 5 different brands use linear LED. So we'll talk about all 5 brands. But first, let's talk about fluorescent. Let's talk about what we're up against, the competition, fluorescent. So fluorescent is a very tough source to beat, as you know. Very efficient, very popular. T8, T5, T12, all very popular. So one, LED needs to be able to beat fluorescent performance on a fixture level. If we can beat performance on a fixture level, we can solve the problem and get LED in ambient spaces. Lifetime. What's the real lifetime story? So elevating versus fluorescent. Very different lifetime calculations, very different lifetime formulas. So how do we really describe the lifetime? So LED really needs to show that lifetime improvement. We know 50,000 hours, we know 60,000 hours for LED. Fluorescence, very good as well in some cases, 20,000, 30,000, 40,000. So we need to be able to solve that lifetime problem. So Cooper's approach to solve 1, 2, and 3 is the platform approach. You'll see here, we'll talk more, it's the linear LED module. We need to be able to see fluorescent, but at the same time, customers need to have that similar feeling of fluorescent. So that's something definitely fluorescent-like. And also something very adaptable. So Cooper, if you've not heard, we have an innovation lab designed, built specifically for LEDs. So reliability testing, electrical testing, a lot of different disciplines there. Optical engineering, mechanical engineering, a lot of different types of engineering. Very good location to really build the LED platforms. Color temperatures, 3,000, 4,000, and 3,500K, and 85 CRI. One problem with LEDs that people are concerned about, LEDs going out. So we have a series parallel matrix. A series parallel matrix that eliminates the problems. If one LED goes out, just one LED goes out. Not a whole string, not a whole bar. So very robust, very reliable. And again, we'll talk more about the 50,000 hours and how that lifetime is generated, and how that lifetime is proven. And again, the color temperatures, 3,000, 3,500, 4,000, really gives you that good blend. And of course, LEDs can very easily go down to 27, go up to 5,000, 6,500. Some data centers might want even higher than that, 8,000. One thing very proprietary and very technically heavy for Cooper is our color averaging. So we use 401 LEDs across the module. In order to get a 3-step or better, we can use color averaging. With many LEDs, you can take the bins from a lot of different places and pull the color back in towards the center. Great color, better color than fluorescent. Let's talk about lifetime. Fluorescent. Fluorescent lifetime calculations are typically based off of failures. So it's not in the case of an LED where moving depreciation down to 70%. LEDs fail, or excuse me, fluorescents fail when the lamp goes out. So when does that lamp really go out? So just a chart here. Look at the average life and just 2 fluorescent lamps. Look at when the lamps start going out, 100% down to 50%. If you look, there's a lot of lights out. So if you're in an office building, there could be many fluorescent lamps out, even before that lifetime of 20,000, 30,000, 40,000 hours for fluorescent. So when does a customer really need to group relamp? They might need to group relamp sooner, maybe 20,000 hours, 15,000 hours. So Cooper, as we talked about, has a very good breadth of line with LEDs. Very good breadth of line. Indoor, outdoor, the recessed indoor, recessed cans. Outdoor were the first on the markets. Ambient really gives us the whole package now. We have all different types of LED solutions, enough to fill a whole building. So very good story there. And let's talk a little bit more about the linear products themselves. Now let's talk about the performance of those linear products and how they stack up versus their